So you're able to see the peak element, right? What is the peak element giving you?
Last element.
So what actually peak?
Last element.
It is not last element, it's the first element. So as per the stack, that is your first element, right?
First, like top element. Like, that is
Last,
the top
but it is
element.
the first element, right? From stack
Okay.
perspective. So that is the element you're able to retrieve it.
Okay.
The only the thing is the stack is something like you're piled upon one above the other. So 4, 5, 6 is the last element, which is nothing but the top element as per the stack. Whereas in your queue, that would be your head element. That is the only difference.
Okay.
So based on the real case scenarios or the real, if suppose you're trying to create your airport management system, and in that case you wanted to say the check-in process, you're going to create your own check-in process code. And in that case, if you wanted to fetch the, what to say, the check-in process happening for the elements of data based on the processing of the people who have come in and not on the order of the ticket IDs, then you can go for queue. Right? You don't need to go necessarily for a list or a stack. You know this is going to be processing and you're going to somehow end up and store it in again an array list or somewhere else. But only the thing is this is ordering. You're just processing it. So whenever you get a request, so for example, if you're working in what to say, in a bank. So what happens? They have the token numbers. When they call the token number, the respective token number holder will go and then perform the activity and then come back. So the token number is getting changed based on the distribution of the tokens happen to the customers. So same way, whenever you have this processing happening, then we might go for the queue. And if we don't have such processing and we are dependent, because you don't need to store those token values, right? It's just an intermediate process to navigate the queue perspective or to navigate the traffic. But this is not the actual way you're going to store the result of the customer. The main details of your customer is the account detail, and then the what is he's doing. He's going to perform a withdrawal or he's going to do a credit. What is going to do action? That is the data you're worried about than the token numbers. So in that case, what you can do is you can go for the queue where you're not dependent on storing the data set, but only for processing that entire customer's information, you need this queue. So based on the use cases, we might use the respective collections or the data structures as and when required. So are we good till here on the stack part?
Yes, Sneha. Yeah.
So you have one more method in the stack to search an element. So how do you have in your map? If you have the element in your map or not, you use contains key or contains value. You have here a method called as search. So you can use that and you can pass the relevant element and you can search it in the stack.
Sneha, like in map we have iterator and all, right? So similarly we have for the stack and queue also those things.
Yeah,
Actually.
you can use the same for each. So that I was about to give you that as an assignment because this stack is something again like your list. If you want to iterate, you can use the normal iterator which you have in your util package and you can still do the iteration.
Okay. For everything we can have the iterator to
Because the stack
look
is
into that.
everything again collection, right? So collection interface, whatever methods you have in your collection interface, all those can be used here. So if you give s1.iterator,
Okay. So,
you're able to see the method iterator.
Yeah.
So you are able to get it, but if you see that is coming from vector package because internally the stack is using the vector collection.
Okay.
You have list iterator also, but internally they are coming from vector, right? So this vector is again similar to array list, but that will be used in a multi-threaded environment. So we'll see about all the multi-threaded environment related collections once we start threads. But this the purpose of them will be similar to whatever you have learned in array list or in the hash map. Everything will remain same. Only thing is you'll not use it in the usual cases. You'll use them in the multi-threaded environments. So once you know what is thread and where we use those, you'll have a better idea to choose the collection type. That's it. So the purpose and the usage is similar. So the main thing is array list, set, and map. These are the main categories. And subcategories and where to use and what, or what are the different types we have under map or under list. Everything can basically classified on the thread platform, whether it is a single threaded or a multi-threaded environment. So once you learn threads, you'll have a more clear idea of which method to choose when and not.
Okay.
Yeah. So hope we are good in this. So I want you to do an iteration on queue and the stack
Stack.
in the iterator, because you are not yet used to iterator. So I want you to make use of that and practice that.
Okay.
And once we are done with this iterator part, yeah, we are good. So we have something called sorted set and sorted map, T set and T map. Okay. So those are the other two things which we need to look on. So now can you just create tree map here? You can, in the same class, just give tree map.
Okay. The search is just, it will search the
Search
element,
the
right?
element
Or
and give you the relevant value, the position where
like boolean
the stack.
position it will give.
Yeah,
Okay.
it will
Okay.
give you the
Okay.
position. Yeah. Now just
Okay.
give tree map. Tree map is again an collection or an interface. You have to tell me. When you type it, we'll see. Tree map. Just give tree map.
Tree map. Oh.
Tree,
Tree map, right?
T. T for
Tree
data.
map. Sorry.
Tree
Okay.
map.
Okay.
Go to that. So that is a class and not an interface. Okay, now can you scroll top of this tree map? Can you just study the first line?
A red black tree based
Implementation.
The map is sorted according to the
Natural ordering of its keys.
natural order of its keys, or by provided at the map creation time, depending on
which constructor is used. So this is like a sorted map, right? So for the hash map or the concurrent hash map, whichever you use, whatever data you insert in it, it will progress in the same way, right? So here, what happens is, if you want to sort your map object, like yesterday we used comparator and comparable, right? Our own interfaces to use our sorting way. Here we can sort it like tree map. So tree map will help us to sort our data.
Okay.
Okay. So now, if you give control O in this class, you can still see again the same contains key, size, get method, contains value, everything is same. Okay. Only thing that changing is the structure is getting changed because you're going to sort it out. Now I request, the assignment for you today is, you have to create a tree map object, do all the map operations, and identify what is the difference between hash map and tree map. So create one hash map object, add the data and iterate it. Create a tree map object and then add the data and iterate it. See what is the difference, what is the value, how is the say, use the same value set. If you have 5 values in your map, use the same value in hash map and tree map, print the object and see what the data is getting different. Okay, see what how this difference is happening in your tree map and hash map, and tell me tomorrow. So we'll just have a higher level discussion on the tree map and sorted map, and we'll wind up tomorrow's session on in the collections part. But I want you to try it out too.
Okay. Okay. Yes.
Okay.
Yeah.
So because this there is nothing should I teach it here, because you know how to create a map, you know how to add the elements to a map, you know how to iterate your map, which is basically you know it. The only thing is, instead of hash map, you're going to use a class called tree map this time. And you have to go and see print and see the results, what is happening. And you know how to create a comparator to iterate or sort your data set, right? Here you have it as a tree map comparator.
Okay. Okay.
Okay. So based on that, we have to see how to do it.
Okay, Sneha.
So we can wrap for today. You can complete this assignment. It should take hardly 5 minutes. So tomorrow we'll just have a discussion, and I'll share you a cheat sheet where you have like I can share you the mail to everyone. So when what is the time complexity of each one? What is the space complexity? And what are the methods like each interface gives us? Like basically the array list, map, hash map. What are the methods you have? If it's a stack, what is it? And what are the iterators you have? And what else you have? Yeah, this is a basic thing. And when to choose what is basically, you know, like the tree map is used for sorting. And what is the time taken, the internal time complexity of tree map, I'll let you know. So whenever you're trying to have a use case and you're trying to build your project, you can use the cheat sheet for a quick reference. And you can use like whether, okay, I don't want tree map because the performance or the time complexity is really high. So I'll go with a hash map. So if I want to show store the null data, then I can go for the hash table instead of having a hash map. So if I don't want to store null data, I can go for hash table. If I want to store null as a key, then I can go for hash map. So you'll have all the important points on each collection point, whichever we learned so far in a cheat sheet. So whenever you use your collections, you can just have a quick look on it and use it as a reference for later developments.
Okay. What is the cheat name you said?
Cheat sheet. I'll share you that tomorrow over the Gmail.
Okay. Okay.
So it will be like it is like more of like key points. Like, okay, list. It is a 0, O of 1 is the space complexity. O of n is the space time complexity. So, okay, it's better to go with array or array list. This would be the structure. So it will help you to figure it out. Okay, you might forget about the complexity when you start developing. So what happens, these sheets will help you to quickly refer and take a decision. That's it. Because you knew what is what and what happens behind, but you might forget what happens because our minds will not have every data at that time, right?
Yeah.
That is the reason I want to share that. So I'll do it by tomorrow.
Okay.
So till now, any questions on collections? So make a note of it. We'll discuss tomorrow on the collections part, and then we'll start on the next concept on the streams.
Sure.
Okay. Yeah. Thank you. Bye. Have a good day.
Thank you. Bye.